Hypothesis test for a population mean. Examples. Sigma is unknown. A local telephone company claims that the average length of a phone call is less than 8 minutes. In a random sample of 61 phone calls, the sample mean was 7.8 minutes and the standard deviation was 0.5 minutes. Is there enough evidence to support this claim at 5% significance level? First, let me write down the given information. You have 61 phone calls. What is that? That is the sample size. So n equals 61. The sample mean was 7.8 minutes. Sample mean we use x bar. Therefore x bar equals 7.8. Then we have the standard deviation was 0.5 minutes. Which standard deviation we have? Is it population standard deviation, which is sigma, or sample standard deviation? It is S. If you don't understand this very clearly, go back to the sentence and read it again. In a random sample of 61 phone calls, the sample mean and the standard deviation. That means the standard deviation is the sample standard deviation. It is S. S equal 0.5. The last 5% significance level. What is the significance level? Alpha. Alpha equal 0.05. Now let's go to the hypothesis testing. What is the first step? Write the hypothesis. Before you write the hypothesis, go back to the claim. What is the claim here? Company claims that the average length of a phone call. That means population average length. Population average we use mu. Mu is the average of the population. So our average length of a phone call is less than 8 minutes. That means mu less than 8 minutes. Therefore, what is the null and alternative hypothesis? They are mu equal 8, mu less than 8 respectively. So, next one is test statistic. Before we find the test statistic, we should understand which test statistic we use. It is Z or T. Therefore, go back to the information. We have sample size and sample average and sample standard deviation. But population standard deviation, sigma, is not given. Therefore, we know when we have sample standard deviation, we should use T naught. T naught equal x bar minus mu naught over S over root 10. So we know x bar. What is the mu naught? Mu naught is the mu value under S naught. That is mu equal 8. Therefore, mu naught equal 8. Then S and N are given. So we can plug these numbers. Then we can have this answer negative 3.124. Then what is the third one? Third one is to find the p-value. Before we find the p-value, go back to the alternative hypothesis. You know alternative hypothesis is mu less than 8. That means it is one-sided and left tail. So how do we find the p-value of left tail test? So go to the degrees of freedom. Degrees of freedom is 60. It is n minus 1. Then we need test statistic. Yes, we have it is 3.124. Therefore, p-value should be probability of t less than or equal negative 3.124. Again, that means area under the curve and left to the negative 3.124. How do we find this area using the table? We know there are no any negative values in the table. Therefore, we can use positive value. Why? Because t distribution is symmetric. Now we can find the probability t greater than or equal 3.124. That means area under the curve and write to the positive 3.124. Now have your t-table ready and find the degrees of freedom here 60. Once you have degrees of freedom, then go back to the test statistic. We are looking for test statistic 3.124 is the positive number in this line. Can we find the positive number positive 3.124 in this line? I don't think so. But we can find two numbers, one less than and other one greater than. It means 3.124 should be in between 2.915 and 3.232. Now go back to the alternative hypothesis, that is mu less than 8, which is one-sided. Therefore, go to the one-sided p-value. Once we have one-sided p-value, our p-value corresponding to the above numbers should be 0.0025 and 0.001. Now think again. Our test statistic 3.124, but we cannot find the exact p-value for that number. Why? We cannot find that number in the table corresponding to 60 degrees of freedom. Therefore, our p-value for this number should be in between 0.001 and 0.0025. Again, we cannot find the exact p-value, but a range for the p-value. Now go back to the problem. We know the range of the p-value. Next step, decision. How do we get the decision? Use the p-value and we reject S0 if the p-value less than or equal alpha. We know alpha equal 0.05 and we know p-value should be less than 0.0025, but alpha 0.05 greater than 0.0025. That means p-value definitely less than 0.05. Therefore, we can say we reject S0 at alpha equal 0.05. So what is the meaning of this? We reject S0, that means we don't accept S0. It means again mu equal 8 is not correct. We do have only two options, so we have to accept HA. Therefore, we can write the conclusion. We have enough evidence to conclude that the average length of a phone call is less than 8 minutes at 5% significance level. Yes, again, we reject S0. Therefore, we have to go with HA. HA is what? Mu less than 8. So, we agree with HA. That means average length of phone call is less than 8 minutes. Thank you.